All right, so we just started the class and said prayer. People are still logging in. We are grateful to have you in the class. And let's see, where can I put this thing? Okay, that's weird. Doesn't move very well. Well, let's leave it there, I guess. Remember, if you have any questions or comments, you can unmute yourself, okay, or and come on the microphone, or if you would like, you can type your questions and comments in the chat. So today we are going to talk more about climate and the atmosphere of Europe, about different types of climates, and the difference between weather and climate. That is an important distinction. And I have the lesson materials there for you, the concepts, what is it that we are going to study, a copy of the presentation, and several links, all right, that I'm going to be referring to here in the class. There's also a very interesting and important talk from General Conference by Elder Watson, being temperate in all things, that we will be discussing later on today. And I have also some reasoning and relating questions and some activities, and one activity and an assignment for you to do that you could turn in if you have any questions, okay? So let's go here to the PowerPoint presentation. All right. And last time we were talking about some of the factors that affect the weather. One of the most important factors that affect the climate of a region is the currents in the oceans, okay? Why is the current of water in the oceans a factor in climate? What happens? What does water do, and how does it affect the climate of a region? Anyone has any ideas? Good. Sabrina and Alex. They conduct heat. Water conducts heat. Okay. So one of the properties of water is that it absorbs heat. Okay. And it also retains heat a lot longer than the surface of the earth, than the ground. Okay. The ground also absorbs heat, but it dissipates, or the heat is removed from the ground much faster than in water. Water maintains the heat a lot longer. You could probably have experienced that, seen that, for example, when you heat up some water, okay, or boil some water for cooking or something like that. How long does it take for that water to cool down, okay, until it's back at room temperature? Is it fast? Is it a fast process or slow process? What do you think? Slow, that's right, excellent, yeah. So it is really a slow process. And that is what happens with the water in the oceans at a much massive scale, all right? So we see that here in the equator and in the tropical zone, the degrees of latitude between the tropics, okay, between 30 degrees south and 30 degrees north and the equator. The sun here, because it's perpendicular to the surface of the earth and the oceans, heats up the surfaces a lot faster, a lot more efficient, okay? On the polar regions, where the sun hits the surface kind of in an incline, a lot of the heat bounces off the surface, and so there's not a lot of heat absorption. When the heat bounces perpendicular, there is a lot more of heat transfer and absorption that way. All right, so that is why in the higher latitudes of the world, okay, both in the North Pole and in the South Pole, below the Arctic Circle, even though you may have sunny days, they doesn't get very warm because again the rays of the sun bounce off and they don't heat up the surfaces very much. All right, so in the equatorial regions you can see the currents of water, okay, how they warm up, okay, and how they travel. And then there is a very, very important current that goes actually, in reality, it also goes inside the Gulf of Mexico and then around Florida, okay? And then it goes through the coast of New England and it's called the Gulf Stream, and, right? And here it's red because it transfers warm water. It's a warm current that normally flows north. It flows the Gulf Stream, it flows around 2 knots, so it's about 2 nautical miles per hour. That is the speed. So it's not extremely fast, but it's fast enough that it moves large amounts of water, and it makes a big difference when you are sailing or navigating where you go, whether you go against the current or with the current, okay? As the Gulf Stream crosses the Atlantic, it changes names and it's called the North Atlantic Drift, all right? And then it separates itself. Part of the water of the current goes south, turns south through the coast of Portugal, and then gets kind of loses its heat, and then it gets into a cold current, the Canary current, until it goes back to the equatorial region and warms up again. And so this water is kind of constantly kind of drifting this way, but it's a conveyor belt of heat. It's really a heat transfer. The northern part of the North Atlantic Drift moves along the coast of Great Britain and Ireland and even into the Arctic Sea by Norway, all right, and it even goes into this area of Russia, okay? So if you have a lot of background noise, you can mute yourself. So this current is really a very important current because it makes it so all the coast of Europe, all the western coast of Europe, is very warm relative to the latitude that it is, all right? So for example, the coast of Norway is almost always free of ice, so it doesn't freeze at all, whereas if you have kind of the same latitude, this area, the Hudson Bay here and Baffin Channel, it completely freezes over during the winter. All right, so the ice totally freezes this part of the ocean. And the reason why here in Europe it remains open is because of this conveyor belt of heat that transfers so much heat there. And I'm not saying that it's so hot that you get into the ocean and you are fine swimming with a swimsuit. Okay, no, it's still cold water, but compared to what it would be in here, it's a lot warmer. So even if you have 5-6 degrees centigrade of difference in the temperature, it makes a big difference for the climate really of all that region. So that is one of the main factors there. So the currents, you can see all the different currents in the world, how they travel and how they move through the globe and how they transfer heat from the warmer areas to the cooler areas and so on. If there's any questions, please type them there in the chat, or you can ask them on the mic. Okay. All right, here there's another same type of graph looking closer into the Gulf Stream, and you see how the warm current moves through the Gulf of Mexico around Florida and Cuba, all right, and it moves there through the coast into the North Atlantic Drift, and it goes through Europe, through all the western coast of Europe, okay, and it transfers the heat here. The lines here in red are the areas where there's a lot of ice, and you see here the legend basically says the different amount of time where there is ice in that area, okay. 6 to 12 months, 6 to 8 months of the year with ice, 4 to 6 months of ice. So, and there's other legends that are outside here of this picture, but you see that this part here in the north, in the Arctic Sea, is covered with ice 6 to 8 months of the year. So most of the time it's totally covered with ice. And you see here also what I was talking about of how the ice even penetrates, you know, in the different, between the channels and the islands there in northern Canada, whereas in the same latitude you have that Norway and even the northern part here of Russia, it remains relatively free of ice throughout the year. Okay, there's here some parts where there's ice part of the year. All right, so very, very interesting. Oh, the vertical lines are the ones where there's ice all year round. That is the permanent ice. The slanted lines here is 6 to 8 months. Okay, 6 to 8 months in this region. So you see that there's a lot of ice buildup, and the Gulf Stream and the North Atlantic Drift make a huge difference into the climate of Europe for that reason. The winds also kind of follow the currents, if you wish. The wind is basically the movement of the gas atmosphere of air throughout the world, and we have that Europe is mainly all. Let me change the pen color to some blue. Okay, let's put some blue here. Okay, to follow through, and so the westerlies winds, these are the prevailing winds of Europe, okay? And they, again, because they go over the Gulf Stream and the North Atlantic Drift, they also pick up humidity, okay, and warm air moves through, and it influences the temperature there in the in Europe. Let me see if there is something here on the chat. Okay, so how did water get warmer in the? How did the water get warmer in the first place? Excellent. So yes, it is in the equator. All right. So let me go back one slide. All right. So as the water goes through the North Atlantic, okay, and it goes closer to the equatorial zone, it warms up. Again, the sun heats up the water, you know, for a long period of time, okay, and it gets very hot. It's a slow moving current, so there's a lot more heat being absorbed by the water. Okay. Yeah, so it cools down as it moves northward, all right? And you see here that in the Canary Current is considered a cold current of water, all right? And then when it gets into the equatorial region, it heats up again. Wouldn't it be cool before heating up when the sun first came to be? You know, so the sun, I don't know which one came first. Okay, apparently there's all reason to believe that the sun started the process again of burning up, you know, and generating heat before the earth was actually formed. Okay, so, and yes, the water retains heat quite a bit, so it is a slow process of losing heat in the water. And here we are talking about, you know, the ocean, so it's massive amounts of water. So again, we have that both the water and the wind causes the continent of Europe to have a lot milder weather than it would if you were considering the latitude. Okay, so you know, so here we have, you know, let's say France. Okay, oops. So let me get the pen. Let me grab the pen again. So we have, for example, France. It would be kind of around the same latitude, okay, as, okay, this area, New England, the Great Lakes, okay, all this area of North America that is very cold, right? It snows a lot, gets a lot of cold winters and everything. The winters in France are very mild, you know, so it does receive some snow, but not much. Okay, there's a lot of rain. Yeah, it means it's true. It means that the water will eventually get warmer again, okay, as it goes back. Yeah. So is it cold there in New Hampshire? Is it already cold, Christina? So, and in Europe it gets cold, but you know, not as cold and is in these regions. The areas of the world where they are farther from the ocean, okay, so the big, massive continental areas don't get the benefit of the heat transfer from the currents, okay? Yeah, so you know, all the area of Siberia in Russia and so on doesn't benefit from that. So it gets very, very cold in those areas that is high latitude and no influence from the ocean currents. Okay. All right. There are also in Europe some local winds. These are kind of local events. Oh, Annika again. Yes. Okay. All right. So now you are here. I thought that you were in La Paz, Bolivia. So I guess that you are here visiting in New Hampshire. Welcome to the U.S. And I imagine that you will be going back to Bolivia. Was there at one point no polar caps? I don't know. I'm not sure. All right. Apparently, the polar caps have been there for a long, long time. There is some evidence that in Antarctica, there was some time when the continent of Antarctica was not frozen. All right. So there are some geological evidence on that. And it also, if it was that way in Antarctica, it was also probably that way in the Arctic, in the North Pole. All right. Study geology, your answers are there. Yeah. So one of the reasons why scientists believe that at some point the polar caps were not there is that they have found some evidence, some fossil evidence of vegetation in the snowpack, below the snowpack and in the rocks of Antarctica. I know. Oh, okay, excellent. Yeah, That's good. So let me go back to this here. Okay. So there are some evidence here in Antarctica in the record of the geological fossil record that shows that there were some time growing trees and other vegetation. And the only explanation that kind of makes sense to me at that time is that it could have been that the axis of the Earth was different at some point in time, all right? Or that the Antarctic continent was not in this position yet. You know how plate tectonics say that the continents move, all right? So there is probably the possibility that the continent of Antarctica was in some other location that was not at the poles. All right, so it's not like the Earth is cooling down, all right? It's the polar caps are cold, and that is just normal, and is expected again because of the little amount of heat that the polar caps receive from the sun. Again, remember, if the sun hits not straight on, then there's not a whole lot of heat transfer. Yeah. So you can keep studying more about that, about what happened with the polar caps. Were they colder? Were there some? We know also from the geological record that there were sometimes some ice ages, they are called, long periods of time where the whole world was colder, okay, and some other times when it was hotter, when it was warmer, more vegetation and things like that show the changes in climate. And most of those, large swings in the climate are probably due to solar activity, changes in solar activity. Yesterday in the science class, we were studying about the sun and how much energy it produces, and that is kind of the main factor affecting the climate in the world. All right, so let's see. So I was going to talk here. This graph shows the Mediterranean Sea. So if you think about it, this is the coast of Africa, the north coast of Africa. You have here Turkey, Greece, Italy, France, and Spain. It's not a very precise map, but kind of a general map, and it shows some of the local winds. There's mainly some winds that come from the north, okay, and they bring colder weather through the Mediterranean coast. And then, as you can imagine, there are some winds coming from the Sahara Desert that bring very hot winds, very hot weather there, okay? So every area has a climate, a specific kind of what is the average expected type of climate for the area. And then there are some local winds or local weather events that happen once in a while, depending on the conditions at some point or another. All right. So let's look now at here this map of the world, looking at all the climate regions. Okay, so what's the difference between climate and weather? I'm going to go here to Wikipedia, all right, and we have here a very good article, a very good, much in detail. It goes into a lot of detail. We are not going to go into all of this, but you can study more on your own. But here we have a good definition of climate. Okay, so it's a measure of the average pattern of variation. Okay, so climate is kind of what is the general patterns of the region. And it measures different variables. Temperature, okay, so that is the heat that is felt in the air, humidity, the amount of water that is, or water vapor that is in the air, atmospheric pressure, and we talk a little bit about atmospheric pressure. We said that it's the weight of the column of air that is above us in the atmosphere. And atmospheric pressure is affected by temperature, okay? So the hotter it gets, the lighter the air is, and so atmospheric pressure goes up also. So the hotter it is, the less atmospheric pressure. The air is hotter, the air expands, and so there's less air above, and that less air weighs less. That is why there's less atmospheric pressure. Also, if you have humidity, if you have high humidity, usually atmospheric pressure goes down. All right? Why? Because if you have more air weighs more, if you have more water in the air, water vapor weighs more, then you would have more atmospheric pressure. The air would weigh more. And the wind is an effect of the movement of air and is closely related to atmospheric pressure. What happens is that if you have areas, let me go here to here and grab the pen. So if you have one area, let's suppose let's get the pen. All right. So if we have one area of high pressure, okay, so you would draw that as, the area of high pressure. Let's suppose here in this area of the Pacific Ocean, there is a high pressure area because the water is warm, okay, and in this part, and so it gathers a lot of humidity, and so it weighs more, there's more air dense, and in here you would have generally a low pressure area, all right? So the air weighs less, there's less air in it, and so what happens is that the air moves usually from high pressure areas to low pressure areas, and that causes wind. So whenever you have wind, you have, the movement of air from a high pressure area to a low pressure area. Precipitation is the amount of water that comes down. Okay, so we have here the article on precipitation, and it is the condensation of atmospheric water that falls under gravity. Okay, so and precipitation includes all of this: drizzle, rain, sleet, snow, graupel, I don't know what that is, and hail. Okay, so you have all sorts of different factors for precipitation. Okay, and there are some other variables. Climate then is the average pattern of all these variables in a given region over a long period of time. Okay, and then it says climate is different from weather in that weather only describes the short-term conditions of these variables. Okay, I like this phrase here. Okay, so let's see here. Oh, let me move this a little bit further. Okay, so I like this phrase here that says, climate is what you expect, weather is what you get. Okay, so climate is the type of weather that you would be expecting given the region and the time of the year, and weather is whatever you get. Sometimes even whether even in an area that is supposedly dry, you get rain. Okay, well, that is a weather effect, not a climate effect. Okay, Does that make sense? So in this article, there's actually a couple of animations that I think are really interesting to look at. So here we see the temperature of the different areas of the world depending on the month of the year. All right, so here we are April, May, and you can see how the temperature changes from the southern to the northern hemisphere. All right, and one of the things that if you look carefully you can see what is the difference between the northern hemisphere and the southern hemisphere, and why? What is the difference between northern hemisphere and southern hemisphere in the temperature? Okay, I'm expecting some comments there in the chat. Mm-hmm. Mm-hmm. Yeah, it's very, very cool. Certainly they are opposite, of course, okay, and we talk about how when it's winter in the northern hemisphere, you know, January, February, March, is summer in the summer hemisphere. And that is because of the inclination of the axis, the tilt of rotation of the Earth. Mm-hmm. Right? What else do you notice between the northern hemisphere and the southern hemisphere? Mm-hmm. Yeah. Yeah. So it is opposite. What else? Yep. Mm-hmm. So Sabrina and Alex Edwards say, doesn't the northern hemisphere, okay, have more landmass? Yes, it has a lot more landmass, all right, both North America and Europe and Asia are a lot more massive in the northern hemisphere. Okay, so there's a lot more landmass in the northern hemisphere than in the southern hemisphere. You see that in the southern hemisphere is a lot of oceans. You have Australia, okay, the tip of Africa, South Africa, and you know most of South America and Antarctica. All right. It doesn't, yes, it doesn't get as cold in the southern hemisphere as it does in the northern hemisphere. It seems like it gets colder in the northern hemisphere. It certainly does. It gets a lot colder. As you can see, the temperatures, you know, the blue, anything that is blue is below zero, okay, freezing temperatures. And so you can see that, you know, we get almost here, this area, of course, is the Himalayas, so very, very high altitude. But see how during the month of winter, okay, you know, it really gets very, very cold here on Asia, all right? All of Europe and Asia get below freezing. What happens in the southern hemisphere, of course, Antarctica, as we would expect, is all frozen, all right? It is below zero. Nothing, you know, very, very little gets above zero. But even South America, all right, even the tip of South America, the city of Ushuaia, all right, let's see when it gets winter. See, it gets some below zero for a couple of months, an average, and that's it, you know. So it snows there in the mountains, but not a whole lot. So the Andes get snow, but none of the Pampas, this is the area where I used to live, it doesn't get that cold at all right? Where if you think of the same latitude, see the same latitude as here, this is, 30-degree line, okay? So the same latitude here, about there, you would see that there's a lot more in the freezing area in winter, okay? Yeah. So it is really weird to get warm Christmases in South America. Yeah, we went swimming on Christmas Day in Uruguay. Certainly in Christmas is the hottest part of the year. So we would always spend it on the beach, on the river, or the ocean having fun. It's one of the hottest times of the year in the Southern Hemisphere, okay? So why does the Northern Hemisphere get so much colder in the winter than the Southern Hemisphere? Why makes it such a huge difference? Yeah, Brazil doesn't get much snow at all. Only gets snow in the high mountains. Okay, but Brazil, lot of rain, but no snow. Yeah, they don't know what snow is. So why is this effect of the Northern Hemisphere getting so much colder than the Southern Hemisphere? It has to do with this comment, okay, that Sabrina and Alex Edwards made. Okay, so what is the reason for the colder climate and temperature average in the northern hemispheres? The tilt in the axis makes the change in the seasons, all right? So, but it doesn't affect it shouldn't really affect that the northern hemisphere is colder, okay? The orbit, no, doesn't even make it any difference, all right? What was it that we were talking about at the beginning of the class? Yeah, when I was growing up in Rosario, that is very close to the same latitude as Uruguay, I remember that I got snow one time in my lifetime. Okay, excellent. So it has more landmass. The northern hemisphere, Owen, good job. It has more landmass. And what is the effect that having more landmass, okay, have? The landmass holds cold. Well, cold is nothing, okay? Cold is really the absence of heat, okay? So you cannot hold cold, okay? What you are not holding is heat, all right? So the land, okay, loses the heat of the summer a lot faster than the water. Remember what we were talking about, the current, how the North Atlantic Drift and the Norwegian current, can you see here the Norwegian current, how it keeps the heat going north? Because the water keeps the heat a lot longer. It takes a lot longer for the heat to transfer. So all this water in the southern hemisphere makes it so the temperature doesn't change that much. Okay. Yeah, so cold is really the absence of heat, but you really cannot define cold. Okay. You can define heat very well, all right, which is energy. Any form of energy is eventually transfers into heat, okay? And so things that are cold are relatively just of less energy. And so what we are talking here of temperature is really that the water holds the energy a lot longer than the ground, than the earth. And so the ground loses the energy, and thus it gets cold. It feels colder. All right. So let me cancel that. No. All right, let's see. I'm going to go to another animation. This one also is very cool. This is kind of similar to the other one. It shows for the satellite image, a composite image of satellite for all the months of 2004. And again, you can see how the ice moves on to, Eurasia, Europe, and Asia, okay, during the winter months. And then this is the summer months, okay, throughout the northern hemisphere. But the southern hemisphere, relatively, the land masses that are not that many, remains pretty much free of ice, of course, except Antarctica. So Antarctica here remains frozen all year round, similar to Greenland. But you also can see even in Greenland in the winter a lot more ice and snow. Okay. There is kind of, a really interesting phenomena here in Iceland, where, see, Iceland is even more northern than the tip of Greenland, but because of all the volcanoes and the geological activity here in Iceland, you have a lot milder weather. Okay. So let me, no, I don't want to do that. I want to go back to this one. Okay. Let's see if there's another animation, I believe. Okay, so this one is the precipitation animation. All right, so this one shows the rainfall and snowfall also through the different months. Okay, so we see how much it rains. All right, so we have millimeters per day. All right, so anything that is green, okay, white is nothing. There's no rainfall. All right, and so if you have anything green, it means that it rains about 2 millimeters per day on average for that month. Anything that is blue is more rainfall than that, and the darker it is, the more rainfall you have per day. So which area in the world has the most rainfall throughout the year? Which are the areas in the world that have more rainfall throughout the year? So Australia, no, it's relatively dry. So you see mainly green. Here in northern Australia, you have precipitation during the winter. Okay. All right, so in South America, just above of where you are. Okay, so Bolivia is this area here. Okay, you see kind of the white. All right, so here you have some precipitation, but it's very dry in the summer months. Very, very dry in the summer months, and then in the summer months is rainy. In the winter months, okay, July, August, winter in the southern hemisphere is very dry. All right, so the area of the world with most precipitation is in Brazil, the Amazon forest. Indonesia gets a lot of precipitation. See, it's blue all throughout the year, Indonesia. Okay, so that area gets precipitation all the time. And then you have here the meridional part of Africa, all right, that also gets precipitation. It goes up and down depending on the time of the year. It follows basically the heat everywhere where there's the summer months, okay, in the northern hemisphere. The summer months here, it rains over in this part, all right? So in Asia, you have in the summer months of Asia, you have in Southeast Asia, India and China get a lot of precipitation. But here in Russia, relatively very little but precipitation, but constant. All throughout the year, you have precipitation. So in the winter months, it gets lots of snow that accumulates and it doesn't go away. Okay, no problem. All right, so very, very interesting animations, these ones. Okay, now what we are going to look at is at the weather regions in Europe. Okay, so here we have the different regions of the climate regions of Europe. So there's a video that you have there in class that shows this very well. And we have the western coast, okay, of Europe and Great Britain having a very wet, okay, and mild weather, all right, so it corresponds to these areas. Then we have in the Mediterranean coast, all the coast of the Mediterranean Sea of Europe, you have a Mediterranean weather pattern that is very much affected by the, oops, it escaped there. Oh, sorry. Okay, so the Mediterranean part, oh my goodness. The Mediterranean part is affected a lot by the winds from North Africa, like we explained, the Sirocco that bring hot wind, and also the Mediterranean Sea. This Mediterranean Sea has very little currents because the waters are pretty much trapped there in the Mediterranean Sea. And so it keeps warming up. It keeps, there's not a whole lot of heat dissipation. So that all that heat of the water is transferred to the weather in the areas around the sea. Okay. In the mountains of Europe, you have an alpine type of weather pattern. So wherever you have the high mountains, you have a lot more rush weather. Okay, this is the Pyrenees mountains and so on. And so you have to look at where the mountains are, and the higher the mountains, the colder it is. Okay. And then we have a large area of Europe with this continental, okay, all the part of Central and Southern Europe and Russia that has a continental humid, okay, type of weather pattern where it has rain and snow in the winter, and is very cold, and again it doesn't receive a lot of the heat from the currents because it's in the middle of the European continent. Okay, all in all, so what we have seen, what we have studied is that the European climate is a lot more temperate than you would expect for the latitude that it is in. So it's a lot milder. And that has allowed really for all the different countries and civilizations to be able to flourish here in Europe. That is really a great thing. Okay, and so the weather the climate in Europe is a lot milder than what you would find in other areas of the world. Okay. Now, what does it mean to be temperate? Okay, or what does it mean to have a temperate weather? All right. I'm going to write the word here, temperate. Okay, so we say that the weather in Europe is temperate. Okay, not temperature. All right. So, okay, let's see here, climates of Europe. And we have this says the climate of Europe is of a temperate continental nature, with a maritime climate prevailing in the north, in the western coast, and Mediterranean climate in the south. Mm-hmm. Where are you, Alec and Natalie? That it just started raining really hard. That's weather. Okay, that's what you get. Excellent, Annika. Very, very good. It doesn't get too extreme, too hot or too cold, and it doesn't change that much. All right. So, oh, you are in Missouri. Excellent. So it's raining a lot. That is kind of expected for this time of the year, isn't it? So yeah. So temperate is that it doesn't get too extreme, too cold or too hot. It doesn't change that much. All right. And that is the type of weather that you see in Europe, again because of all the reasons that we were explaining and talking about. Okay, so we see how the Gulf Stream affects that, the precipitation patterns, the temperature averages there in Europe. Okay, and so the temperature of Europe is temperate. It doesn't change too drastically. Okay. Now, there's a talk that Elder Watson gave, Kent D. Watson. He gave in the October 2002 General Conference, and it's titled Being Temperate in All Things. There are several scriptures that talk about the word temperate. I would really invite you to kind of do a word study and study this word. Search the word temperate in the scriptures. Okay? So the talk starts, it says, in response to the prophet Joseph Smith's inquiry, the Lord instructed, and no one can assist in this work except he shall be humble, full of love, having faith, hope, and charity, being temperate in all things, whatsoever shall be entrusted to his care. Okay. So the talk goes on and explaining about what is temperance, or what it means being temperate in all things. And so I'm going to ask you the questions, and there are several scriptures that talk about. So type in the chat area, what do you think that it means, okay, when the scriptures say being temperate in all things? Okay. Remember what temperate is related to weather. How does that apply to people? The talk also explains that Jesus Christ was the main example of temperance, mild manner. Okay, don't get mad and have patience. Excellent, good question, good answers. Keep going. Mm-hmm. How did Jesus Christ show that he was temperate? How did he show by his example of being temperate? Mm-hmm. He was always nice. Don't get extreme. It's important to be in control of anger. That is excellent. Very good answers. He loved everyone. He was loving and rarely got mad. In fact, the only time in the scriptures where he said that he did something, I wouldn't say violent, but he did something forcefully, was when he was in the temple and took the people that were selling things from the temple. He was calm and forgiven, so he would not get mad. Yeah. So see this part here in the talk. It says, when Jesus Christ, the greatest of all, suffered for us to the extent that he bled from every pore, he did not express anger or revile in suffering. Okay. With unsurpassed self-restraint and temperance, his thoughts were not of himself, but of you and me. And then in humility and full of love, he said, nevertheless, glory be to the Father, and I partook and finished my preparations unto the children of men. So imagine when Christ was suffering the agony of the atonement for all the sins of all of us, he did not complain. He remained calm and he remained focused on being forgiving. Okay. He didn't get mad with those that scourged him or nailed him to the cross. So that is the highest example of temperance. So this is one of the qualities that we need to also develop. All right, not getting too hot in our climate, okay, but remember that in order to qualify to assist in this work, okay, we need to strive to be temperate in all things, okay. So that was also another thing that we saw here in this animation. Remember the animation that we were looking at the temperature. The southern hemisphere is more temperate than the northern hemisphere. The changes in the northern hemisphere are a lot larger in temperature than in the northern hemisphere. It doesn't change that much. Okay. So very, very interesting thing and very important attribute that we need to remember to develop. Okay. So I invite you and all of us that we may pray for help in order to be more temperate, more calm and forgiving, okay, being able to control our anger and remain under control. And I wanted to share these things in the name of Jesus Christ. Amen. With all of you. Okay. Who could we have to say a prayer? Who would be